we consider the question of the compound interest problem, where we start with a $10,000 investment which is compounded annually at a 7% interest rate. We see that the growth rate for this function is 7% or 0.07. The growth factor, the factor by which we multiply the principal to get the principal a year later, is 1 plus the 0.07. The 1 because we keep our principal, the 0.07 because we add 7% to what we keep. It follows that if we start with an amount p sub 0, after a year we're going to have p sub 0 times 1.07. After 2 years, well, we start with p0. At 1 year we have p0 times 1.07, and then we multiply that again by our growth factor, 1.07, and we end up with principal at time, clock time t equal to p naught times 1.07 raised to the t power. And if t equals 2, that means that p of 2 is p naught times 1.07 to the second power. The number of years is the number of times we multiply by 1.07, so that after t years we're going to multiply by 1.07 t times, which is the same as multiplying by 1.07 raised to the t. Our function therefore is p of t equals $10,000 times 1.07 raised to the t, because our initial principal is $10,000. We can graph the general behavior of this function and see that we'll double from $10,000 to $20,000 over some period delta t. This curve is the approximate shape of an exponential function, getting steeper and steeper as we multiply the 1.07 by greater and greater numbers. By trial and error, we can figure that the doubling time here is approximately between 10 and 11 years. We don't know exactly what the doubling time is, but we could figure it out. As a matter of fact, we can set up this equation. 10,000 times 1.07 times t sub d, where t sub d stands for doubling time, equals 20,000. That is, we start with 10,000 and take the interest rate 1.07 for t sub d years, we should end up with 20,000 if t sub d is the doubling time. We divide both sides by 10,000 and quickly get the equation 1.07 to the t sub d equals 2. And at this point we're not really expected to be able to solve this, but I'm going to go over the solution anyhow. We take the logarithm of both sides. If we remember that the logarithm of a number to a power is the power times the logarithm of the number, that is, log of a to the b is b log a, we can write this side as td log 7 after taking the log, and that'll equal the log of the other side, log 2. We immediately see then that t sub d is log 2 over the log of 1.07.